dear friends, welcome to Gate Academy Global. So let me focus over the agenda behind today's video. We are going to take around 7 to 8 different kinds of the problem based on the concept of second order transfer function. So before going to start today's session, I would like to have the input as well as concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go ahead. So I have planned to take around 8 different kinds of the problem. 8 different kinds of the problem. Many of us might have seen this problem, but still we are going to learn few of the new concepts with the help of each and individual question. So here comes the first question. See, watch this problem carefully and try to get me the best most answer for this given problem. The problem states, which of the following system has the maximum peak overshoot due to a unit step input? The 4 different options were given. The first option had been 100 divided by s square plus of 10 of s plus of 100. B had been 100 divided by s square plus of 15 times of s plus of 100. C had been 100 divided by s square plus of 5s plus of 100, and similarly the D had been 100 divided by s square plus of 20s plus of 100. Tell me what would be the best most answer for this given problem. This problem had been experienced by the electrical people in year of 2017. The problem was framed by IIT Roorkee. Tell me what would be the best most answer for this given problem. So the answer has started coming. As per the Subham Sri Pai, the answer had been C. Anyone else apart from Subham Sri Pai? Tell me. Anyone else apart from the one answer which we have received over the live chat? According to him, the answer had been C. Answer had been C. Once you read this problem carefully, at least few of the important conclusions you could have retrieved. We have been talking a situation where the output had been going beyond the steady state value. That is why the word had been the peak overshoot. No, overshoot, what does it mean of it? That means the response went beyond its steady state value. May you know what it takes place? It takes place only and only when the value of zeta is in between 0 to 1, neither 0 nor 1. In case of 0, it would be keep oscillating, and if it goes 1 or beyond 1, it would be pure exponent. It would not overcross, it would not overshoot its steady state value. So one thing has been quite sure, as far as this problem is being concerned, the value of zeta has to be in between 0 to 1, neither 0 nor 1. So out of the 4 different options which we have been looking for, obviously the zeta has to be in between 0 to 1. Now what happens as the value of zeta increases? The damping coefficient increases. As the damping coefficient increases, what happens? Now the system starts decreasing its oscillation, and as the system starts decreasing its oscillation, what would happen? The worth of overshoot is continuously decaying. So what I am saying, the range has to be in between 0 to 1, and if you want to have the maximum peak overshoot, in that case the value of zeta has to be as minimum as possible. As minimum as possible, because as the value of zeta would increase, definitely the peak overshoot would start decreasing. So tell me what would be the best most answer for this given problem. So let me focus over the first question first. As I was communicating in the last class, whenever you had to focus over the omega n, do not look over the numerator, because the numerator used to have k times of omega n square. Just focus over the denominator. 100 had been in place of omega n square, so the omega n is going to be 10. And this 10 had come because of 2 zeta omega n is equals to of 10 where the value of omega n has been already 10. So 10 and 10 goes out, the value of zeta had been 1 upon 2. So obviously it had been an underdamped system where the response would go beyond its steady state value, but we will see with the rest 3 number of options where the zeta had been minimum. Similarly, see, here it had been 10, here it had been 15, the omega n has not been changed. And if the omega n has not been changed and the factor of 2 zeta omega n had been increased, one thing has been quite sure, is still the minimal most value of zeta between option A and B had been option A only. Yes. In the same sequence, if you go ahead with the option C, Again, the omega n had been very same, but instead the 10, now the factor which we had over here has been the 5. So obviously the value of zeta had been decreased. So if I take the reference of 1, 2 and 3, where the value of zeta had been minimal, at least in starting 3 options, the C had the minimal value of zeta. And similarly, if I take the reference of this, which had been in place of 2 zeta omega n, which had been 20, the value of omega n had been 10. 10 into 2, that's gonna be 20, and hence the value of zeta has been found to be 1. And here you can say it has not been an underdamped system. That means there would not be any oscillation at all. So this has been the ruled out case, because there would not be the oscillation, and hence there would not be any case of overshooting. A, C and B, which had the minimal most value of zeta, and that had been C. So the best most answer is gonna be option C. Best most answer is gonna be option C. So the 3 different kinds of the answer we have got it. One had come from the Subham, the second had come from Amit, and Subham is saying the underdamped system. Obviously it has to be an underdamped system. If you really want to understand how its output curve would look like, what we can do, we can draw its output curve also. If it's been excited with the unit step input, may I know what would be its steady state value? I would like to have the input from each one of you. What would be its steady state value? The steady state value used to be the value of k. May I know what had been the value of k over here? The value of k had been very same, because here it used to be omega n square, here it used to be omega n square. Could you understand what I am saying? Omega n square into k. So if I take the option A, B, C and D, everywhere the value of k had been 1. This would be obviously underdamped, this would be underdamped, this would be underdamped, and this has been critically damped, where the response is going to be exponent in nature. If I take the reference of underdamped system, the response would be oscillating, and its oscillation would be keep suppressed, and it would held down to the magnitude k, and the k had been 1. And similarly, as the value of zeta would increase, now what would happen? Do you know that? As the value of zeta would increase, the nature of oscillation would be keep decreasing. So I can say here it had been zeta. One thing is quite sure, if the nature of the system had been underdamped or oscillating with a damped frequency, so here the zeta would be in between 0 to 1. You can take, let's take the zeta had been somewhere 0.2, and here the zeta had been 0. Let's take 5. One thing is been quite sure, peak overshoot. What does that mean by the overshoot? How much extra value is being taken by the response, taking the reference of its steady state value. Where it was more, here it was lesser, but here it has been more. And where it had been more, where the value of zeta had been lesser. So obviously, as per that concept, the value of, or the option C had been the perfect most answer. The C has been the perfect most answer. So probably this concept must be clearly understood to all of us. And if we'll talk about maximum peak overshoot, that used to be k 1 plus e to the power of minus zeta pi root over of 1 minus of zeta square. And this concept is defined only and only when the zeta is being in between 0 to 1. If the zeta goes beyond 1, what would happen? The iota would be created, and it would become e to the power of iota theta. Obviously, it would not be a valid overshoot. So this particular value is being valid only for this. So I can say, if you talk about the peak value, the peak magnitude, it would be k 1 plus e to the power of minus pi zeta root over of 1 minus of zeta square. If you guys are having any sort of doubt, you can ask over here. Otherwise, we would move into the next question. So from here, at least one conclusion we can retrieve. The oscillation towards output in the form of damped oscillation would take place only if the zeta is being in between 0 to 1. That's the first thing. Secondly, as the value of zeta would increase, it would start increasing its oscillation. And as the oscillation pravritti is increasing, what would happen? Its peak overshoot would increase its magnitude. So I think till this point, each and everything must be clear to all of us. So let me move forward, taking the next question. Here had come the next question, and this problem had been experienced by the electrical people in engineering services examination in year of 2001. Let me bring this problem towards working board, and I would give around 1 minute to crack this problem out. It's not a very difficult question, but I can say it may take a little bit effort while solving. Again, around 90 seconds has been given to you guys. Tell me what would be the best most answer for this given problem. The problem states a second order system. Yes, sir. It had been a second order system. If you know little a bit about the differential equation, the highest derivative is being defining that order of the system. So obviously it's going to be the second order system. The following differential equation, 4 times of d square ct by of dt square plus of 8 times of dct by of dt plus of 16 times of ct is equals to of 16 times of ut. The damping ratio and the natural frequency for this system are respectively. The 4 different options were attached along with this problem. The option A had been the value of damping ratio is been 0.25. Similarly, the natural frequency of the oscillation which had been attached with the first option is been 0.5 to 0.254, 0.54. Tell me what would be the best most answer for this given problem. What would be the best most answer for this given problem? What would be the best most answer for this given problem? Just a minute, let me switch off my phone. Yeah, everything is fine. So the answer will started coming. As per the Amit, answer would be B. Anyone else apart from the Amit who can endorse the answer which had been given by the Amit has been the perfect one? Tell me. Still 30 seconds been left out. What would be the best most answer for this given problem? My dear friend, whenever the second order system is being given in a form of differential equation, no, many of the students fears a lot. But I think it's just a way to represent the same system. The system has been represented in Laplace domain, which becomes k omega n square divided by s square plus of 2 zeta omega n plus of omega n square. Even this complete transfer function has been brought from the differential form of the equation only. Yes. So what we can do over here, what had been the C of t? Obviously the C of t had been the controlled output. And once you'll see this problem carefully, you'll get to know the 16 times of ut had been the form of input. So what we are going to do, we are going to arrange this problem into the standard format first. The 4 had been the common factor, as the 4 had been the common factor towards left hand side as well as right hand side. So let me rub the common factor of 4 in both of the side. Once we do so, the result which comes in our hand is been d square of ct dc square plus of 2 times of dct by of dt, and here it goes plus 16 times of 6 c of t is equals to of 4 times of u of t. Keep in mind it had been 4 only, no, it had been 4 only. If you will take the Laplace transformation both other side, if we have taken the Laplace transformation both other side, it would become s square of c of s, keeping all of the initial conditions 0. So it becomes s square of c of s. Similarly, it becomes 2 times of s times of c of s, and here it becomes 4 times of c of s, and here it becomes 4 times of 1 upon s. So let me take the Laplace both other side. Laplace both side. We are going to take the Laplace both side. And once we have been taking the Laplace both side, the resultant which we are going to have, it's going to be s square of c of s plus of 2 times of s of c of s, and here it's going to be 4 times of c of s is equals to of 4 divided by f. Could you understand what exactly I wanted to communicate? Now what we are going to do over here, do one thing. Output in Laplace domain, c of s had been brought one side and the remaining component had been shifted towards the right hand side. So here it became 4 divided by of s getting multiplied with the s square plus of 2s plus of 4 plus of 4 plus of 4. If I would like to ask from each one of you, the input which has been applied to the system, is being u of t 4 times of u of t or 16 times of u of t, if we have presumed the value of k for the given transfer function is being 1. Should I repeat what I exactly wanted to communicate? What I am saying, I have presumed the value of k which had been provided by this system is being 1. In that case, tell me the second order system had been excited by which input? It had been excited with 4 times of ut, whether it had been excited with the 16 times of ut, or whether it had been excited with the ut alone. Tell me what would be the bestmost answer. Once you'll see this problem carefully now, you'll find this 4 and 4 had been very same. That means it had been omega n square and it had been omega n square. The value of k is already been taken as 1. So put together this 4 divided by s square plus of 2s plus of 4 had been the standard form of the second order equation, keeping the value of k as 1. So what I am going to do over here, let me draw the system into its equivalent block diagram. So here it goes the input, here comes the output, and the system is being defined by 4 divided by s square plus of 2s plus of 4, and may I know it's going to get multiplied with which factor? 1 upon s, and hence I can say the reference input which we have applied to this system is being 1 upon s or u of t. 1 upon s or u of t. So you can say the input was u of t, and in that case the response c of s is going to be the convolution between the u of t and the system, or in Laplace domain it would be just and just multiplication. Could you really understood what exactly I wanted to communicate? Because I know many of the students would have a good amount of doubt. They would say the input had been 16, somebody would say the input had been 4, somebody would say the input had been u. No, the input had been u of t. The input had been u of t. Agreed? No? Exactly, we can't say the input had been u of t because k could have been something different also. No, k could have been something different. If k could have been 2, in that case you had to take the input as a half times of ut. If the k had been half, in that time the input has to be 2 times of ut, because more or less we had to satisfy the requirement of this differential form of the equation. Could you really understood what I am saying? So now I think it's piece of cake. Easily, by substituting the standard form of the transfer function, you must be able to get the value of damping ratio as well as the natural frequency of oscillation. May I know how the natural frequency of the oscillation would be calculated? Just focus over this transfer function, which used to be omega n square divided by of s square plus of 2 zeta omega ns, and here it had been omega n square. Once we compare both, we get to know the natural frequency of oscillation has been 2 radian per second. It had been, and once we are done with that, now if we would be focusing over this value of zeta, the value of zeta would be 2 times of zeta into omega n. The omega n is already been known to me, and that had been 2 only. So the value of zeta is going to be 0.5. So more or less the two data which were expected to be calculated within this problem is being omega n as well as zeta. So obviously the omega n had been 2, and as well as the zeta had been 0.5. So the answer which we are supposed to get after doing this all calculation, which answer it had been? Omega n had been, omega n had been where it had been 2, and here. The B is gonna be the bestmost answer. I know many of these students must have been made certain mistake. Agreed? No. If the 4 would have been absent from here, what I am saying, if the 4 would have been absent from here, in that case you could have taken the 16 is coming in place of omega n square, and there the value of omega n would have been 4. I know many of these students had been pretended that had been the location of omega n square, and hence the value of omega n is being 4. But that would be the case if this form had been the standard form of the second order transfer function, which starts from s square, which does not have any multiplier factor, which used to be only and only 1. So the bestmost answer is gonna be B. So 28 come into the equation. How 28 come? 28? 2s it is, my dear friend. 2s it is. It's not 20s. I have been taking its Laplace transformation both other side. No. So it's gonna be s times of c of s. It's gonna be 2 times of s times of c of s. If you guys are having any sort of doubt, you can ask here itself. Otherwise, it's right time to move into the next question. So what I am saying, be ready. Many of the times rather giving the standard form of the second order transfer function, they used to give the relationship between the input and output in time domain itself. And I have seen most of the time the students are well comfortable, well acquainted dealing with the problem into the Laplace domain of the second order system. But yes, they have given the equivalent differential form. So I think again this has been a mistake prone question. The first mistake the student can do, they can get the value of omega n as 4. No sir, the omega n could be 4 only and only if there had not been any multiplier factor, and at the same time the concept of the omega n would come into the picture when the system had been an underdamped system. You yourself would be able to analyze it had been an underdamped system. How did I know about it? The value of omega n, it had been 2 into 2, that had been 4. The value of zeta had been 1 upon 4, 2 upon 4, that had been 0.5. Keeping all things in our mind, the best most answer which we have been receiving after doing this all stuff of calculation is been B. In the same sequence, I think it's the right time to move into the next question. And here comes the next question. It won't be a very difficult question, but I would say, yeah, it is a good question. Within 1 minute, you must be able to tell me what would be the answer for this given problem. This has been the third question of the day. Let me bring this problem towards working board and we would try to smash that problem there itself. Read the problem carefully and tell me what would be the best most answer. The solution of the differential equation d square x by of dt square plus of dx by of dt plus of 2 times of x is equals to of 1 is critically damped, underdamped, overdamped, and probably there had been certain mistaken part over here, but anyways, out of 3 different options which we had been attached along with this problem, tell me what would be the best most answer. So the answer had started coming. Amit Kumar says the answer would be B. Jayanta Hajra says the answer would be underdamped. Okay. Again the fundamental remains very same. If you will convert this complete problem into the standard form of the second order system, you yourself would be able to understand the Laplace of 1 would be 1 upon s, provided the signal of the system had been the one-sided signal of the system. If you will take the Laplace of this complete left hand side, which will make it s square of x of s, 2 times of x of s plus of 2 times of x of s. Agreed what I am saying? So what I am doing, taking the Laplace both other sides. And once we will do so, you will get to know towards left hand side it's simply going to be s square x of s, initial condition has been dropped, plus of 2 times of s times of x of s, 2 times of x of s, and here it became 1 divided by s. So here you can say the response given by the second order system, x of s is being 1 upon s getting multiplied with the s square 2s plus of 2. So what I am saying, again you had to arrange this problem into the standard form, and once you do so, this 2 should come over here. So it had been 2. To compensate that 2, you had to divide 2, and here it had been s square plus of 2s plus of 2. What does that mean of it? That means it had been a system whose transfer function is being defined as 2 divided by s square 2s plus 2, and had been excited by, you can say, half times of u of t. Could you understand what exactly I have been talking about? Or you could have taken the factor of k as half. What I am saying, you can adjust the factor of k either with u of t, either with the transfer function itself. The half has to get multiplied, the half can be multiplied over here, the half can be multiplied over here. There is no doubt as such. But in this problem, they have been seeking for the type of the system it had been. What I am saying, here there had not been any multiplier factor. The value of zeta definitely is in between 0 to 1. So in that case, you just had to focus over this factor. This factor has been the factor of omega n square. The omega n square has been 2. The value of omega n had been 2. This 2 had been at the place of 2 zeta omega n, and that had been 2 where the value of omega n is already been known to be root over of 2, which used to be 1.414 something. And once you multiply 2 into 1.414, their multiplication would be greater than value of 2. So the value of zeta is simply going to be 2 with the value which had been greater than 2. So a value of zeta is going to be in between 0 to 1. It's going to be an underdamped system. It's going to be underdamped system. Now I would like to ask, how would be the response of this system tentatively? As the T increases, obviously oscillation would be continuously decreasing. May I know what would be its steady state worth? The steady state worth is going to be K. It's not exactly K. The steady state worth was K when the input was U of T. But now the input had been half times of U of T. So what is going to happen? Initially it was going to get settled at K, where the value of K had been 1. Now the K is going to get multiplied with half, and it would get settled at half. Even with the help of final value theorem, you could have got the same answer. You could have got the same answer. Yes, no? So let me go forward. Here goes the question number 4. Just a minute. Read this problem carefully and tell me what would be the best most answer which we would be getting for the question number 4. This problem had been experienced by the electronics people in the year of 1999. The problem was framed by IIT Bombay. Yeah, here it had been the problem. Read the problem carefully and tell me what would be the best most answer for this given problem. The problem states, for a second order system with the closed loop transfer function T of S is equals to 9 divided by S square plus of 4S plus of 9, the settling time for the 2% band in seconds is, the 4 different options were attached along with this problem, is being 1.5, 2.0, 3.0, 4.0. Tell me what would be the best most answer for this given problem. What does it mean by the settling time? The settling time is the time taken by the system to get settled down to its steady state value. Theoretically speaking, it takes infinite amount of time. That is why we used to calculate the settling time with a certain error band, certain tolerance. And here the tolerance had been taken as 2%. What does it mean by the 2%? That means if the output or response settles down within the tolerance of plus minus of 2%, I would be more than happy and I would say, yes sir, I have reached to my settling point or steady state. So once you read this problem carefully, what I am saying, you had been just initially with zeta times of omega n, because the settling time with a 2% error band is being defined as 4 divided by zeta omega n. I am not going into the detailed derivation part of it, because that is not at all required for the electrical as well as electronics as well as instrumentation, even you take the reference of gate or ESC. 4 divided by zeta omega n, and this concept is true only and only when the system is being the underdamped system. Obviously, the system had been the underdamped system. When you will calculate the value of zeta, you will get to know the value of zeta had been falling in between 0 to 1. Omega n had been 3, 2 into 3, that's going to be 4, 4 divided by 6, obviously the value of zeta had been 0 to 1. Focus over the zeta omega n. My dear friend, the value of omega n square is being 9. From here, the value of omega n is being 3. Omega n is being 3. The 4 had been in the place of 2 times of zeta omega n. Zeta omega n is equals to 4. And here the zeta had been, just a minute, 2 it had been, no? 2 it had been. Yeah, that is what I was telling, no? Anyways, keep aside each and everything. The 4 had been in the place of 2 times of zeta omega n. So the value of zeta omega n which we have got out of it, it's been 2. So the value which we are going to get out of it is being 2 divided by 2, 4 divided by 2, and that's going to be 2 seconds. What does that mean of it? Practically speaking, the underdamped system reduces its oscillation over the period of time. And when it goes towards a 2% tolerance of its steady state value, let's take its steady state value, it's been at K. First time, if it goes within the 2% tolerance, what I am saying, 2% tolerance. What does that mean by the 2% tolerance? If you go beyond 2% of K, that's going to be K 1 plus 2%, and that's nothing but the 1.02, and here it's going to be K 0.98. So you can see the first time the system had reached within the tolerance of 2%, within the tolerance of 2%, within the tolerance of 2%, and thereafter it had been bounded within the range of plus minus of 2%. So this time is going to be called as a settling time, and approximately it had been taken as 4 times of 1 upon zeta omega n, and here we have found this as 2 seconds. So again, one of the important conclusion we could have retrieved out of it, as the value of zeta omega n is going to increase, the value of t set is going to be reduced, or I can say the transient part would be keep shrinking. If omega n had been kept as it is, and if this factor is being keep increasing, what would happen? The settling time would occur earlier, Yes. May you know what would be its steady state value? If the input which has been applied to the system, it's been 2 times of ut, what would be the response? Tell me, what would be the response? Again, if we'll talk about the standard form of the transfer function, the value of k had been 1, because the value of omega n square towards downside and the value of k omega n square towards upside had been very same. The value of k had been 1. 1 is going to get multiplied with 2, so the value of k which we have been receiving out of it, it's been 2. Yes. So probably this concept must be clearly known to all of us. Okay. In the same sequence, let me move forward, and let me take the question number 5 over there. So here comes the question number 5. Read this problem carefully and tell me what would be the best most answer for this given problem. Read this problem carefully and try to get the best most answer. The problem states the system g of s is equals to 0.8 divided by s square plus of s minus 2 is subjected to a input. What does that mean? A step input. That means this has been the transfer function of the system, and the input which had been exciting the system had been a unit step input u of t. In Laplace domain, it's been the 1 upon s. The system output y of t, when the t had been tending towards 0, infinity, that means you had been seeking for the steady state response of the system when the system is being excited by the unit step input. Tell me what would be the best most answer. What would be the best most answer for this given problem? What would be the best most answer for this given problem? Subham, there is certain mistake which you have been doing over there. Read this problem carefully and try to figure it out. Certain twist had been introduced within this problem. Tell me what would be the best most answer. So the 2 different kinds of the answer we have received so far, all of us are wrong. Subham Sri, wrong answer. Subham Sri again wrong answer. DS has been wrong answer. Jayanta Hazara has been the wrong answer. Amit Kumar had been giving the answer as D. Probably that's only the perfect most answer. Yes. What I'm saying, once you read this problem carefully, you had a system. Let's take the system has been represented by the block which has been excited from the left hand side, and the output had been taken from the right hand side. Let's take the input is being taken as a small r of t in the time domain, and similarly the output had been taken as a small c of t in time domain. And in the Laplace domain, the c r of t had been taken as r of s, and similarly c of t is being taken as c of s. Could you understand what I am saying? And the transfer function is being clearly known to me, that had been 0.8 s square s minus of 2. Agree, sir? No, sir. What I am saying, the input had been clearly given along with this problem. It had been u of t. So may I know what would be the output? In time domain, it's going to be the convolution between u of t as well as the transfer function in time domain. But the c of s is going to be 1 upon s, is going to get multiplication with 0.8 divided by s square plus s minus of 2. This has been the output in Laplace domain. As far as this problem is being concerned, you have been looking for the final value or the steady state value of the response, obviously in time domain. I could have used the final value theorem. where the C of S is clearly known to me. That had been 1 upon S square plus of S minus of 2, and here it had been 0.8. My dear friend, nobody should use the final value theorem, at least in this problem. No means nobody should use the final value theorem. Final value theorem is not applicable specifically for this function of Laplace, because if you talk about S square plus of S minus of 2, not even 1, the 2 pole had gone 1, 1, 1, 1, yes, 1 pole had gone towards right hand side. One pole had gone towards right hand side, and as the one pole has gone towards the right hand side, the system would be an unstable system, or I can say the final value theorem has not been applicable. May you know what had been the validity of the final value theorem? The final value theorem can be applied over a time domain C of t only and only if S times of C of S has all of the poles at the left hand side of the S plane. Neither of the poles should be there, or origin, neither of the poles should be there, or the j omega axis, neither of the poles should be there towards the right hand side of the S plane. As far as the steady state value C of S is being concerned, if C of S is going to get multiplied with S, obviously everything vanishes. So you just focus over the S square plus of S minus 2. When you would be focusing over the S square plus of S minus 2, you yourself would be able to understand. Let's take it's been S square, let's take it's been S, let's take it's been a S naught. So here the factor is going to be 1. Here the factor which comes is going to be 1, and here the factor which comes is being 2, and now the last factor is being 2. Is there any sign change? Yes sir, there had been a sign change. That means one pole of S times of CS had gone towards right hand side. What does that mean of it? That means it had been an unbounded signal. It had been an unbounded signal, and as it has been an unbounded signal, one thing has been quite sure, it had not been converging to a finite predefined value. Steady state value would be going towards a plus infinity, might be minus infinity, or it might be keep shooting up and down, but its steady state value is not possible. I know many of the students, what they have done, they have fed S is equals to 0, and when they have been feeding S is equals to 0, simply they had been left out with a 0.8 divided by minus of 2, and they had given the answer as 0.4. Neither C nor A nor B. The option D is going to be the best most answer. Option D is going to be the best most answer. Could you understand what I am saying? Exactly, if you would like to see how this curve would look like, focus over the value of zeta. May I know what would be the value of zeta? What would be the value of zeta? You yourself would be able to calculate that, and from there you would be able to calculate each and everything. You would be able to calculate each and everything. It would be expanded into two exponent form. Probably one exponent form would be the decaying exponent form. The another exponent form is going to be the increasing exponent form. No, we can't do that. What I am saying, but yes, we can predict the value of C t around 0 plus. Tell me, what would be the initial value of the response? What would be the initial value of the response? Because in the same problem, they could have introduced another problem. Rather focusing over the steady state value, they could have framed the problem in such, they could have asked the steady state value as well as the initial value both. So the steady state value had got to known to be unbounded. Tell me what's going to be the initial value. Whether the initial value theorem can be applied or not, or whether we would be able to get the exact value of the initial value or not, that you tell me. What's going to be the initial value? My dear friend, for the initial value, I do not had been much concern. As far as the initial values theory is concerned, the degree of numerator should not be equals to or greater than the degree of denominator. Otherwise, in that case, it becomes a improper form of the function. Agreed, no? And that has not been happening. If we talk about the numerator does not carry any of the S component. That means the degree of numerator is being 0. And similarly, if we talk about the degree of denominator, the degree of denominator had been 3. The S gets multiplied with the S square. So the highest term of S which had been present towards the denominator side is been 3. Yes. So initial value theorem is ready to be used. How the initial value theorem is being used? It's been written as limit S rather tending towards 0. It tends towards infinity, and here it goes S times of 1 upon S, the complete factor, no? 0.8 divided by S square plus of S minus of 2. One thing has been quite so, what I am saying, whenever you have been feeding, a certain variable tends to infinity, and if the degree of denominator is being higher than the degree of numerator, the resultant would be 0. If the degree of numerator has been higher than the degree of denominator, the resultant would be infinity. And if the degree of numerator as well as denominator had been very same, in that case we goes into a non-zero finite value. But here it had been pure 0. Here it had been pure 0. Yes, no? So at least this thing must have been clear to all of us. Must have been clear to all of us. What I am saying, let me take on problem. Let me take a problem. We had a system. Let's take, we had a system over there. The system is going to get excited with the different inputs. For the time being, I have fixed my input to the unit step input, and let's say it's been the u of t. This has been the second form of the transfer function, and it's a t of s, and let's see, it's the output in time domain. It's been written as a y of t. Tell me, how would be the waveform of the output if the system is being taken somewhere. It's been 4 s square 2 4 2. Okay, it's been 2 times of s plus of 4. My dear friend, whenever you have this sort of problem, no, just focus over the value of k, just focus over the value of zeta. May you know what had been the value of k? It had been the place of omega n square, it had been the place of k times of omega n square. The value of k had been 1, and the input is been ut. That means the steady state response is going to be settled at k, and that had been 1, provided it has to be a stable system. So what I am saying, if you'll focus over the value of zeta had been 0.5, yes, and similarly if you'll focus over the k had been 1. So it is going to be an underdamped system. That means it would oscillate with the damped nature. It would be keep decreasing its magnitude, and it would get settled down at 1. Could you really understood what exactly I wanted to communicate over there? Yes. Now let me change this system a bit. Rather taking 4, I have taken this as 8 s square plus of 2s plus of 4. Only one change had been noticed over here. The k had reached from 1 to 2. Zeta had been still 0.5. It would be an underdamped system which would be oscillating with the decreasing magnitude, and now it would get settled at rather settling at 1, it would be settled at 2. Agreed? Let me change this problem a bit. Let's take, rather taking 8, I have taken this as a minus of 8. 2s plus of 4. Here the value of k had been minus of 2 and the zeta had been 0.5. Once in a while this problem do come into the GATE examination, and I know most of the students are not able to solve this problem out. Here it had been t, here it had been y of t. See what had been happening. The k had been a multiplier factor, that had been minus 2. Minus 2 is going to get multiplied with this complete y of t, like 2 had got multiplied. Now if the minus sign is going to get multiplied, this complete signal would be folded taking the reference of x-axis. It would go towards downside, and then it would get expanded, So here it becomes, how would be the response? Response would be something like this, and now it is trying to go towards the steady state. And may I know what would be the worth over there? It's going to be minus of 2. Yes, it would be in fourth quadrant. Anyways, it can't go into the second as well as third quadrant, because we have presumed the signal as well as the system which we had been using in control system had been one-sided, or the causal system. So till this point, I don't find any of the student would have any sort of doubt now. Agreed? No? Now what we are going to do deliberately, let me change the transfer function of the system a bit. Still the input had been u of t, but the input had been, transfer function has been changed a bit. See, it had been 4 again, it had been s square, it had been minus, rather having plus, we have taken minus 2s plus of 4. And here what had been happening, the value of k had been 1, the value of zeta had been minus of 0.5. As we have seen earlier, whenever the value of zeta had been lesser than 0, the system had been an unstable system, and the system has been the unstable system, and when it's been excited with the unit step, output would always be unbounded in nature. May you know, when the zeta is in between 0 to minus 1, the nature of poles are gonna be complex conjugate with the positive real part. Like we had complex conjugate with the negative real part. Whenever the zeta is being 0 to 1 or 0 to minus 1, there would be oscillation. There would be oscillation. When it is towards plus side, the oscillation would be keep decreasing over the period of time, and if it is being the right hand side, it would be keep expanding with respect to the time. So what I am saying, the zeta is being minus of 0.5, no? There would be the oscillation. Would it be the increasing oscillation? Would it be a decreasing oscillation? That's the point to discuss on. So obviously it's going to be increasing oscillatory. Increasing oscillatory. They may ask this sort of problem. They may ask this sort of problem. Yes, because they used to be concerned more over the positive value of zeta, but even for the unstable system also they may ask this sort of problem. This sort of problem. Let me test the next question what I have been doing over here. Let's say the problem is being 4 divided by of s square plus of 4s plus of 4, and again this system had been excited by the unit step. It's been excited by the unit step. The same fundamental we had to use. The value of k had been 1, the value of k had been 1, and here the value of zeta had been 1. Zeta had been 1. As the value of zeta had been 1, it's going to be the pure exponent. But whether the initial or the final value theorem can be applied, obviously can apply here. What I am saying, the s times of c of s should not go towards right hand side. That's all. That's all. So what I am saying, the initial and final value theorem can be applied at any moment of point if the standard second order system had the value of zeta greater than 0. Either it's been in between 0 to 1, either it's been 1, either it's been greater than 1. Because in that case, the initial as well as final value theorem remains very same. So what I am saying, neither the initial value which has been 0 nor the final value which has been 1 had changed. Only and only nature of the response is going to change. Initially, it was oscillating with the damping nature, and now it would be pure exponent. Yes, t, and here it's going to be y of t. Here it's going to be y of t. Could you understand, Indrajit? I can understand your feeling, but this global channel has been meant for communicating the concept over the English alone. So obviously we had to follow that protocol. No issue, Indrajit. I think you can follow my lecture very well, because my English is also not that good. I just wanted to communicate my feeling to you guys, so probably you would be able to connect me very well, because I am also from Hindi medium. But still our agenda had been very clear. In global, we want to connect across the country, because I have been there in southern part of our country. The students are not much friendlier with Hindi, so obviously they should also understand the thing in the proper way. That is why the mode of communication which we have selected over this particular channel is being English alone. For negative zeta, FVT can't be applicable. Obviously it can't be. Not only that, if when rather taking plus of 4, if you will take minus of 4, no? What I am saying, keeping aside each and everything, if either of the pole goes towards right hand side, the final value theorem is not been applicable. Now let's take this coefficient is been 1. Let's take this has been positive in place of omega n square. So now the pole can go towards right hand side just because of this sign to be negative. So what I am saying, if this has been the positive, this has been the positive, just focus over the zeta. If zeta had been the negative value, the final value theorem is not applicable, but the initial value theorem would be applicable, because initial value theorem is nothing to do with the locations of the pole. It has to do only with the number of poles and the number of zeros the given function carries. Yes. Subham Sripai, perfectly well. If you guys are having any sort of doubt, you can ask over here itself. Now let me say the next one. Now the system had been taken as s square. Instead taking plus, I have taken minus 4 of s plus of 4. In that case, what's happening over here? Again, the final value theorem cannot be applied. There is no doubt in it, the final value theorem cannot be applied. And as the final value theorem cannot be applied, obviously you would not be able to predict its final value. But one thing has been quite sure. If you will focus over this function thoroughly, no, it had been s minus 2 which has been raised to the power of 2. Yes, s minus 2 which has been raised to the power of 2. So it's going somewhere t times of sine of t. Anyways, keeping aside each and everything, just focus over the value of zeta. The value of zeta had been minus of 1. Whenever the zeta goes beyond plus of 1 equals to 1, whenever zeta goes beyond minus of 1 including minus of 1, there would be only and only exponent waveform, and here it had been keep increasing and would go towards infinity. Like here it was keep oscillating and still the output was unbounded. Here it was keep raising exponentially and now going towards the infinity. It is going towards infinity. Yes, no? I think this is more than adequate to briefly understand the response because of the excitation as the input for the different transfer functions. Agreed, no? I think it is the right time to take the next question. So let me do one thing. Let me go back into the PDF which we have prepared for you guys and come down to the next question. Yeah, here had been the next question. The second order system has the following properties. The damping ratio zeta is being 0.5 and underdamped natural frequency of oscillation is being 10. The steady state value of the output to a unit step input is 1.02. The transfer function of the system is being. This problem had been experienced by the electrical people in GATE year of 2016. The problem was framed by ISC Bangalore. So what I am saying, let me briefly bring this problem towards working board. I can say it's a comparatively superior problem because 2 or 3 different informations has to get satisfied by the given numerical, and hence I can say it's been a superior problem, not a difficult one but superior problem. Tell me what would be the bestmost answer for this given problem. Tell me what would be the bestmost answer for the given problem. See, the second order real system has the following properties. The value of zeta has to be 0.5 and omega n has to be 10. If omega n is required to be 10, no. Basically towards the denominator side we had the constant coefficient omega n square and that should be 100. So obviously option A, option C, option B and option D all had the constant coefficient as 100, at least in terms of omega n. They had not been different. Next, the required value of zeta is being 0.5. May I know what used to be the multiplier of S? The multiplier of S used to be 2 times of zeta into omega n, where the value of zeta is required to be 0.5, where the value of omega n is required to be 10. So here it becomes 2 into 0.5, that's simply 1 getting multiplied with 10, and here the result is supposed to be 10. That means A has been ruled out because here it had been 5. Similarly, D had been ruled out because it had been the 5, and similarly you had been left out with the C and B. Yes. And now they had been focusing over the steady state value. Although the value of zeta, omega n had been very same, but their steady state value had been very different. If it had been excited with the u of t, what would be its steady state value? It's going to be limit s tends to 0, 1 upon s, s is going to go out, this becomes 0, this becomes 0, its steady state value has been 1.02 and its steady state value had been 1. So what I am saying, its response because zeta had been 0.5, it would be settled at 1 and it would be settled at 1.02. Like this, 1.02. So as per the requirement which has been raised within this problem, the bestmost answer which we are going to add is going to be option B. It's going to be option B. In the same sequence, I think is the right time to move forward and take the next question. Here goes few of the graphical question. Yeah. Read this problem carefully and tell me what would be the bestmost answer for this given problem. Read the problem carefully. Input is 1.02. Who said? One student is saying the input had been 1.02. Just a minute. The output to a unit step input. Here the comma is being used. That means this was supposed to be output for the unit step input. Okay. So the B is only the correct answer. Read this problem carefully and tell me what would be the bestmost answer. Read this problem carefully and tell me what would be the bestmost answer for this given problem. What would be the best most answer for this given problem? Tell me what would be the best most answer for this given problem. Only one answer had been received so far. As per the Subham Sri Pai, answer had been A. As per the Amit, the answer had been B. Anyone else apart from the two answers which we have received so far? The best most answer is going to be option B. Read the problem carefully. That is what I was repeating this sentence once again. Out of the figure shown below, one represents the impulse response. They had not been discussing about the unit step response. They had been discussing about the impulse response. If you take the reference of a standard second order system, that used to be k omega n square divided by s square plus of 2 zeta omega ns plus of omega n square, and it had been under damped system. What does that mean of it? It remains a stable system. The value of zeta would be in between 0 to 1. And as you had been finding its final value theorem, may you know what would be its final value theorem? It's going to be limit s tends to 0 s times of the transfer function itself. Why transfer function itself? Because the input had been the unit impulse, and as the input had been unit impulse, the output is going to be the transfer function itself. Transfer function into 1, that would become the response itself. Whether the final value theorem can be applied or not, obviously sir, we can, because zeta had been underdamped in nature, and once you'll apply the final value theorem, one thing has been quite sure. The s is being the multiplier factor loosely towards numerator. When s would be fed as 0, the resultant which is going to come in our hand, it's going to be 0. Obviously it would be keep decreasing and it would go towards 0. Not only that, if you'll apply the initial value theorem that used to be limit s tends to infinity, s times of this complete structure once again. If we'll talk about the degree of numerator, the degree of numerator is going to be 1, degree of denominator is going to be 2. Whenever we had the limit towards infinity, degree towards numerator is lesser than denominator, the resultant would again be 0. Could you really understood what exactly I wanted to communicate through this? And because of zeta, where the pole had been symmetrically located over the symmetrically located, having the negative real part and complex conjugate form, there would be the oscillation. So again I say this has been the initial value at t is equals to 0 plus, and that had been 0, and it had been the steady state value when the t had been tending towards infinity, and that had been 0. So again I am saying, so far we had been habitual that whenever the question is going to get raised, the questions would be coming from the unit step response, but deliberately rather giving the focus or rather giving the input or excitation as the unit step, they had given the excitation as the unit impulse itself or impulse itself. Yes, no? I think it's right time to move forward, taking the next question. Here goes the next question, and probably is going to be the last question also. Read this problem carefully and try to get its best most answer. The problem states the differential equation 100 times of d square y by of dt square minus of 20 times of dy by dt plus of y is equals to f x t describes the system with the input x of t and the output y of t. The system which is initially relaxed, the initial condition has been dropped, is excited by the unit step. The input x of t is being u of t. The output y of t can be represented by the following waveform. Tell me what would be the best most answer. What would be the best most answer? When you would be comparing with the standard second order system, one thing has been quite sure. The value of negative indicates whatever you do, the value of zeta would be negative. And as the value of zeta is being negative, the output would never ever will reach to the converging steady state value. C has been confinedly ruled out. B has been ruled out, D has been ruled out. So anywhere you had been left out with the option A only. But here it would be exponent and raising only and only if the value of zeta is lesser than minus 1, like it could be minus of 1.1, 1.2, minus of 2, minus of 3, minus of 4. So once you will calculate the value of zeta, now you yourself would be able to understand the value of zeta had been lesser than minus 1. That is why it had been unstable and that too exponent in nature. My dear friend, in between I am going to take few of the series where I would consolidate only and only tougher problem of the control system, only and only tougher part of the control system. Probably maybe within 2 to 3 days I will plan. I would give the complete scenario over the thumbnail itself. In that day we would discuss only and only tough problem of the control system, tough problem of the control system. If you guys are having any sort of doubt till this moment of point, you can raise your doubt here itself. Otherwise we would go forward with the next video, obviously, which would be coming exactly at 3 p.m. in tomorrow's class. Tell me, you guys are having any sort of doubt till this point? If no doubt, we can close the today's session. Okay then. This is all. We would meet tomorrow precisely. Okay. Sir, will you be taking complete control systems question? Yes. I am going to take that. Subham, I would like to ask one thing, whether you are enhancing your technical knowledge over the control system by learning the concept through the question. You must reply the answer with a yes or no, because you had been following my video since very beginning. So you are the person who can give the better feedback. Whether you are learning the concept through the different questions which we have been considering over this particular video. So your feedback would be definitely important for me. Sir, how much in detail I need to study for state space? If you are from electronics, I would say you just follow your syllabus. Nothing more, nothing less. Yes, I would try to go till state space. So far our agenda had been same. My agenda had been, yes sir, concept are crystal and clear. That's fine now. That's fine then. So total 10 number of students are being live. May I know how many number of students who had been from the south and southern part of the country? And exactly, can you tell me guys exactly from which state you guys are from and in which district you are from? So I will have the better understanding who all had been following our videos. So definitely I would put more effort. The two input, state and district. The student who are from the southern part of our country. Probably, okay, Odisha. You are from Odisha. Okay, Subham. DS, you are from? Okay, Chhattisgarh, Raigad. That's fine. Still few more number of students who have been following us in the regular basis, no? Probably Amit, you had been following me. May I know you are from? Okay. Anyways, no issue. Precisely at 3 p.m. we are going to meet with the same in Patna. Amit Kumar, okay, then it's fine. Amit and DS, you guys had given few number of feedback. Definitely, I thought to implement that also. I am going to take the separate videos for the difficult most problem of the control system which had been experienced so far. So definitely in that day we are going to take the tough problem only, and probably we are going to mix few of the new questions which had been come in past 2 to 3 years. Sriza, okay, Telangana, Warangal, you are from Warangal, that's fine. Once I had been there in my friend's marriage. Okay then, this is all about the today's class. We are going to meet exactly from Begusarai, Bihar. Okay, sir, I have been watched almost all of you video on crash course. It helped me a lot. Thanks, dear Asif. So okay, this has been the agenda of today's class. Probably the next class would also be based on the concept of second order system. We would take few more number of problems in that video precisely in between 3 to 4 p.m. Till then, bye bye, take care, good night.